Okay, so I think I have these. Hopefully, I'm doing the ones that I assigned. Alright, here we go. A little tad bigger. Can I? Yeah. Alright, so there's a lot of things that the question is asking. And suppose you receive $100 and deposit in the savings account. Every week thereafter, you add the account. So you must be tired of questions like this by now. But first, let's get to. Now, when it says X and Y, it's talking about the dependent and independent, right? So what is the Y here? So the Y is going to be, right, what we're going to label the Y-axis, the total in your account. Okay. And the X is going to be the weeks, right? Because you're depositing $5 for weeks. So when we do our graph, we can go ahead and write total in account. I mean, you don't have to write total in account, but total is fine. And then here is the number of weeks, right? So what happens to your, so the total in your account depends on the number of weeks, right? Can we get the equation? Well, let's get to the equation here. Where can I write the equation? Well, the equation is easy to write, right? Y equals 100, 5x plus 100. What does that mean? Well, it's linear. It's not proportional, right? Because our the account at 0 weeks, and let's pretend this is 100. At 0 weeks, which is right here, your account starts with 100. It's going to be linear, but it's not going to be proportional. Okay. So the slope, yeah, well, the slope is 5. Oh, I have room for the equation here. Sorry. Equation equals y equals 5x plus 100. The y-intercept is going to be 100. And I need a point. Well, I have a point already. I know that at 0 weeks, I'm going to have $1. So I already have 1 point. When will the account have $310? All right. So we can, let's see. Let's create a table. So x, and in the middle it's 5x plus 100. And then the y, and then the x and y coordinate, right? So if you really were to do this, that's what I would want from you. Now this is going to help us create the scales here. So week 0, we already know that's 5 times 0 plus 100. So 5 times 0 is 0, so I'll have $100 in my account. So I'm going to start at 0 weeks and have 100. Let's do, because it says when will the account have $310? One thing we can do here is, I'm trying to figure out 10. Let's do this by 10. 50, hang on a second, 10. What if I do 10, 20, 30, 40, 50, 250? All right, I can do by 10. So let's do, what happens at 10 weeks? Well, it'd be 5 times 10 plus 100, and that's going to give me 150. At 20 weeks, it would be 5 times 20 plus 100. It's going to give me 200. So let me write 10 and 150. That's another point that I have. I have another point here, 20 and 200. Let me go 30. At 30 weeks, it would be 5, right? $5 for every week. So times 30 is 150 plus 100. And 5 times 30 is 150 plus 50, 150, get 250. Ooh, and then at 35 weeks, sorry, let's do 40 weeks. At 40 weeks, it'd be 5 times 40 plus 100, and that's going to give 200, it's going to be 300. So let's see if we can graph that. So weeks is on my x-axis, which is my independent, so I'm going to write independent here. Independent, right? My input, my y-axis, my total, or my output, my dependent. There's a lot of things. So 0 weeks, let's make every 200. Yeah, we can do every every 400. Well, let's do every 400. So again, I want, then the more spacing I have, the closer I am going to be. 1, 2, 3, 4. No. So let's do every 2. 100. I'm going to do every 4. 100. 1, 2, 3, 4. That's 200. I know. 1, 2, 3, 4. And about here, right? And I know we're running out. That's 300. And then 305. And then 310 will be just right up there. So, what do we have here? 0 and 100 have a point, and I just put that point in there. Second point is 10 and 150, so 10 weeks will be 150. 150 is just here, right? 100, halfway between 100 and 200 is 150. 30 weeks, I'll be at 250. 30 weeks. And 20 weeks, I'll be at 20 weeks, I'll be at 200. So 20 weeks, 10, 20 weeks, 30 weeks, 40 weeks, 50 weeks. At 20 weeks, I'll be at 200. At 30 weeks, I'll be at 250. And at 40 weeks, I'll be at, what do you call, 300. Right, there's 300 over there. Let's draw a line. So let me just make that line a little prettier. Right. Maybe I shouldn't use that scale. So again, let me go that, go like this. The line has a name. It's going to be called y equals 5x plus 100. But it still doesn't, I mean, we can't, that's 300 and here would be 400, right? So 310, which is what the question is asking, would be around here. And then we can't tell exactly what it is. So in this case, well, because my graph, there's another way we can do this. So if you think about it, number of weeks, right? X represents the number of weeks, and the Y represents the total, the output. So this is what I have right now. So I'm missing this value, right? I'm missing the X value. So yes, we can do it visually. Obviously, I didn't do too good of a job here, but we can use the equation. Y equals 5x plus 100. We have the Y value, and we need the X value. So using the equation of the line, right, we can just substitute. So I know that, so I'm asking you, when Y equals 310, so when my total is 310, what is the number of weeks, right? What's that number of weeks that it took to reach that point? So 5x plus 100. Now we can solve that, right? It's just a two-step equation. So minus 100, minus 100. That goes away. We're left with 210 over here, which equals 5x. Divide both sides by 5, right? And we get that x equals 42, which, again, if you look at the graph, and we're at 310, which is, I mean, that's 200, and 400 is over here, right? 310 is this over here, this value. So let me see if I can match it. And again, we're doing this, right? And there is my point right there, and I'll put it in green. So visually, sort of, we're in the correct area. We just can't tell exactly what the value is, right? But the other way of doing it was be to use the equation. Okay, unless you get a better graph and you use a better scale than I did, you're more than welcome to do that. Maybe I used the wrong graph. All right. Okay. Yeah, that's it. Hopefully, I'm doing the right question. Next one. Again. Okay. I wonder if I can change graphs. Give me a second. Let's see if I can find a different graph. Not that graph, not that graph. This one. If I can copy and paste. I can get rid of it. No, I can't get rid of it. Oh no. Oh, I can't get rid of it. All right, so we'll just use that. Okay, I'll figure something out. 2, 3, 4, 5. Yeah, it's the same size. All right, next question. Same thing. A lot of things they're asking. So let's read the information. So an airplane is at 30,000 feet above ground, begins descending at a rate of 2,000 per feet. So the airplane is here, right? So our question is going to start at this point. And again, right away, it gives you the y-intercept. The question starts here. So at 0 minutes, right, when we set our clock, right, this is what's going to be happening. Every second, or is it every minute, the airplane obviously is descending, is going to lose altitude. So after 1 minute from the moment the plane starts descending, obviously it's not 30,000 feet, it's at what? Well, it's losing 2,000, so it'd be at 1 minute, it'd be at 28,000 feet, at 2 minutes, it would be at 26, and 3 minutes, 24, etc., right? So, 28, 26, 24. So that's what we want to graph. So I just got to do a better job here in making this. Maybe I can, hang on a second. Maybe I can do something better here. Maybe not. Maybe yes. All right, so let's see if I can take that picture away. Go back here. Maybe get rid of seriously. Okay, give me a second. Sorry, apologize. Go back. Look at this. Okay. Make that bigger. Okay, I don't think this is going to be as pretty, but I can just focus on the first quadrant. And don't ask me why I didn't think of this, or why I used 4 quadrant. We're only using 1 quadrant. So get that, X, go over here, paste. All right, so it's a little bit better. Okay, so we have an x-axis and we're only dealing with the y, first quadrant. So 30,000 feet, airplane is descending, right? So a point on this, right away I know that it's going to be 0 and 30,000, right? I have points, so that's, I know a point, x and y, right? That's a point on this line. And it just happens that it's my, what do you call, y-intercept, okay? What is the equation going to look like? Well, the equation is going to look like y equals, well, it's going to be a negative slope. So here's your slope, right? 2,000 feet per minute. So we're going to write 2,000 minus 2,000 x plus 30,000. So very similar to one of the problems we have today. And I'm going to take that and write it over here because nobody can see it. Y equals minus 2,000 x plus 30,000. Which happens to be our y-intercept. Where is the plane after 5 minutes? Okay, I can do this one. So 0, so on the x-axis, which is our time, I'm going to write minutes, and the y-axis represents our altitude. All right, so here we can actually, thank God it only goes 5 minutes, so we can go 1, 2, 3, 4, 5. Okay, and then 30,000 feet, 10, 20, 30. Let's make this 5, 10, 15. All right, let's go every 5. So this is 10,000 feet. This is 20,000 feet. And this is 30,000 feet. I guess we could have done every 3 boxes is 10,000. So let me do that because I have room. So this is 10,000 feet. So we're going to be. This is 20,000 feet. And this is 30,000 feet. A little better. So our y-intercept, well, we have our y-intercept. This is going to be 30,000. we have the equation. The x represents the minutes that pass, and the y represents the altitude. So the altitude here, the height of the airplane depends on the minutes. The slope is minus 2,000. Right? Where's the airplane after 5 minutes? Well, let's see if we can do it. Well, let's create a table. X, what's the equation? Minus 2,000x plus 30,000. Then you have your y value, and then your x and y coordinate. Right. So when x at 0, right, at 0 minutes, the airplane is going to be at 30,000. Right. So 0, so it's going to be negative 2,000 times 0 plus 30,000, and that's going to give us 30,000. So 3, and my first point is 0 and 30,000. After 1 minute, the airplane obviously times 1 plus 30,000. So the airplane lost 2,000 in altitude feet, so it's going to be 28,000. So after 1 minute, the airplane is at 28,000. Okay, so you get the point, right? So, like I said, we only need 2 points. So 0, so the airplane, let me change colors. Let me use red, I guess. The airplane starts right here. Right, so the airplane is flying, and then the pilot comes up and says, hey, we started our descent. So the airplane is going like this, and now it's finally starting to go like that, right? The descent portion here to your destination. All right, so 0 minutes. After 1 minute, it says here that the airplane's at 28,000. So let's look for 28,000. So this is 23, 26, so 28,000 should be around here, right? At 2 minutes, it's going to be 2,000 times 2, which is 4,000. So the airplane is going to be at 26,000. So 2 minutes is going to be 26,000. I'll write it down. At 3 minutes, it's going to be at 24,000. Right? At 4 minutes, it's going to be at 22,000. And at 5 minutes, it's going to be at 20,000. Oh, we know the answer. So here we go. 2 and 2 minutes is 26, which is right about here. At 3 minutes, it's going to be at 24. Sorry, 24 should be a little bit higher. Sorry. 1 minute is 28,000. Okay, so let me just put that a little higher. 1 minute's going to be 28,000. So this guy over here. Maybe we should have done the twos. At 3 minutes, going to be at 2 minutes, going to be 26,000, which is above that line. At 3 minutes, it's going to be 22,000. 24,000, apologies. About here. 4 minutes, going to be 22,000. And at 5 minutes, it's going to be at 20,000. So, you know what? Let me actually erase these. So the easier way is probably to draw this line here. Okay. And then I can be more precise. There we go. And then arrow gives your equation a name. Y equals negative 2,000 x plus 30,000. Now let me go back to point. So 1, look, oh, much easier. Look, at 1 minute, there's my 20,000. At 2 minutes is 26. It's right here. 3 minutes is 24,000. It's right here. 4 minutes is going to be 22,000. So look, I can find my points much easier. So that's one way visually. So again, that was one, and then the question actually says, right, so you have your points. So look at the point. 1 minute, 20,000. 2 minutes, 26. 3 minutes, 24. 4 minutes, 22. 5 minutes, 20,000. So the actual question was actually this. Here's x, right? So when x is 5, what was the y value? So again, going back to the equation. So if you have the equation, y equals negative 2,000, x plus 30,000, and you're looking for one of the two coordinates, right? And they give you x, so all you have to do literally was substitute here, right? So you get y equals negative 20,000, sorry, 2,000 times 5, which is the x value, plus 30,000. Y equals, and that's 10,000, negative 10,000, plus 30,000. And our y value, which we already knew, was 20,000. So there you go, just to confirm. And again, you can use the equation to your advantage. Okay, Alexa, stop. All right, thank you, Alexa, stop. All right, so that was that question. Let me just take advantage and copy this. This guy. All right, so Marty's spending some money at an average rate of $3 per day. After 14 days, he has $68 left. Ooh. Uh-oh. What's this guy doing? All right. So let's graph this. This one might be a little tricky. Do we have a point? Yeah, we have a point right here. At 14 days, he has $68. So there's my X and Y. So the y-axis represents the money he has. Let's just go with this. The money he has. And obviously the x-axis represents days. 14, let's see, 1, 2, 2, 4, 6, 8, 10, 12. I'm going to go by 2. So 2, 4, 6, 8, 10, 12, 14. So at 14, he already had, at 14 days, he has $68. So 10, 20, 30, 40, 50, 60, 70. So again, let me label some numbers here. 50. I mean, I'm not going out of order here, but I'm trying to put in the information that I have. So at 68, at day 14, he's about here with his money. Okay. So it says he's spending money at an average rate of $3 per day. So we know the slope is going to be negative because that money is decreasing as time goes by. Okay. So if we start writing, so X represents the number of days. Y represents the total money he has left. So put it like that. The slope, we have a slope here. The slope is $3. So sorry, the slope is 3, right? So we can start writing that equation. Y equals negative, sorry, I should have put negative 3x plus b. That's all I have. I don't know how much he started with. Did he start with, I mean, obviously he didn't start with $10, so it has to be any value above 68. Did he start with 80, 90, 100, 120? So we know that this line is going to go look something like that. Sorry, over the point, right? So we're sort of working backwards here. I have a slope. Okay, I don't have the y-intercept, but guess what? I have a y value and I have an x value right here. That's an x and a y. So as long as I have that and I have the slope, I can figure out what we started with. So let's substitute. So the y here is 68. Negative 3 times, and the x is 14 plus b, which is my y-intercept. So 68, what is this? 3 times 4 is 12, 42, negative 42 plus b, where it's a one-step equation. So we're going to add, let's add 42 to both sides. That goes away. Let me add 42 to the other side. And that is 110. So look at that. The b, which is my y-intercept, is 110. So let me add just another line here. Thank God. That's what I started with. So I'm going to put a little green dot here. That's what he starts with. So the equation, now I can actually write my full equation. Y equals negative 3x plus 110. So here is his story. He starts the account with 110 and he loses $3 every single day. Okay. So you could have done that. I mean, if you really had the time and if you really, really wanted to, you could have, again, created a table. And what do we know here? Well, could you? Well, you could have, once you have the equation, created the table, and done the whole process. And I'll erase this in a second. So right now I have 2 points, which is pretty much what I need. Let me create a line that goes through these 2 points. Let me just push this a little bit out. There you go. And again, if you wanted to extend this, and when this hit this, you would know that he would have 0. So another question that could have been asked is, when will he have $0? Well, that's not the question, so we won't worry about. But let's give the equation, the line. Let's give the equation. The line a name. Y equals negative 3x plus 110. Okay, and then here, then you can go and find at 12, he had this much. At 10 days, he had this much. And 8 days, he had this much. 6 days, so, and all that. But the question here says, what did he start with? So the answer to that is 110. Okay. All right, so far so good. Relatively simple. Get rid of this line. That's the last one. No, get rid of this line. Copy that. Oh, there's one more. Get rid of this guy. Paste. Copy. Paste. Alright, so let's see if we have information for everything here. Make that a little greater. Julio, sorry. Did I just say Julio? Julio is on a diet. He wants to lose 0.2 kilograms a day or 200 grams a day. After 14 days, he weighs 40 kilos. Same thing. How long will it take to? Plans a diet to gain. I am sorry. He wants to gain. So maybe he's working out and he wants to add on 10 pounds of muscle. Wow, 10 pounds, 10 kilograms of muscle. That's a lot. After 14 days, he weighs 40 kilograms. How long will it reach 50? So it's like the previous problem, very, very similar. So right off the bat, you have a point. So we know that at 14 days, he's going to weigh 40 kilos. So that sort of helps me, I imagine. So again, I'm going to make this, we're going to go by 2, 6, 8, 10, 12, 14. I'm just going to keep adding because 18, 20. So I know that, and then up and down, what should we make? So now the slope. Slope is going to be 0.2. X represents the days. And y-axis is going to present his total weight. And again, I can't get my equation. Right? I got y equals 0.2x, so 0.2 per day. Is that what he gains? Right? Plus b. I don't know what the y-intercept is. So we know that this line is going to go up like this, right? So at 14 days, he was at 40 kilos. So what did he start? What was his weight at, what do you call, at whatever, day 1, at day 0. That's what we're looking for. Okay. Again, we have an x and y. We have an x and y coordinate we can substitute. We have a y value. We have a x value. We don't have the y-intercept. Do we have the slope? Yeah, the slope is right here. So we can go ahead and now substitute. So when he's 40, at 40 kilos, 0.2 times 14 plus b. Okay, so 0.2 times 14, oops, 1 second, is 2.8. So 40 equals 2.8 plus b. Now we're going to subtract 2.8 from both sides. And b is 37.2. So our y-intercept is 37.2. So we're going to go y equals 0.2 x plus 37.2. And that's my y. So that's the equation of my y. Now, how am I going to do this? 10, no. All right, I'm going to do 3 again to my, every 3 boxes. 10, no, I can't do that. Every 2 boxes, 10. 20, 30, 40, 50. So on day 0 of his diet, Julio was 37.2. 37.2, I'm going to change colors. To approximate here. So we have a point that on 0, the day, right, day 0 of his diet, his weight was 37.2. We have another point, and it says at 14 days, oh, thank God, I forgot about it. At 14 days, his weight was 40. So here's my other point. All right, so I'm going to draw a line here. Oh, where's my line? Connecting these two. Right, so notice that it's a very, very slow growth, right? 0.2 every day, as you can tell. There you go, a little better. Let's call it arrow here, call the equation y equals 0.2x plus 37.2. Oops. 37.2. Okay, so, and again, on day 2, what was it? I mean, we can't really tell from this graph, but you can tell that he's growing 200 grams, right? Every day. So it says at 50 kilos, when will he be 50 kilos? Wow, so 50 kilos, I forgot that was the question. So 50 kilos, we're going to have to stretch this line, right? And again, it'd be, and this line would go on and on. So here, remember the 50 is over here. So if you extend this line, right, and this line here would meet him all the way far away there that we can't see on the graph. So again, let me put everything back. Y equals 0.2x plus 37.2. Unless I changed, I don't want to change. So again, we'll see that it meets. So another way of finding that value when what day he's going to reach 50 kilos. So think about it as in terms of a coordinate point. This is what we have. We know that when will the y value be 50? When the y value is 50, what is the x value? So that's basically what the question is asking. Well, if you have the equation, you can use the equation. And let's substitute. So y is 50. So when will he be 50? After how many days? So 0.2x is 37.2. Okay, now comes the tedious part. Minus 37.2. Minus 37.2. So we subtract those. 50 minus 37.2 is, what do you call it? 12.8 equals, those goes away, 0.2x, and we're going to divide both sides by 0.2. And finally we get that x equals, oops, 12.8 divided by 0.2, 64. It's going to take him 64 days, right? 64 days for him to reach his goal of 50 kilos. So now again, look at my x-axis. So that's 20, 22, 24. So 50 would be outside my laptop here, and that's where this line here, right, is a very not so steep slope. It's going to meet 50 all the way. Again, I wish I could push that outside. All right, so the answer is 64. Okay. All right, so hopefully that helps you with yours. Okay.